Jai Hind. Today we can do some numericals relating electric flux and Gauss's law. As a review, these are the formula we have studied last class. The formula for electric flux, the Gauss's theorem and the applications of Gauss's theorem. Okay, now we move on to the first question. A charge Q is placed at the center of a cube. What is the flux coming out from one face? So there is a cube, we can draw a cube. So consider a cube and a charge Q is placed at the center of the cube. Here is the charge Q at the center. Okay, charge Q is placed at the center of the cube. What is the flux coming out from one face? We know from Gauss's theorem what is the total electric flux. Phi equals Q upon epsilon 0. So that is the total flux passing through the surface is equal to 1 by epsilon 0 times the charge enclosed. So this is the total flux coming out from the surface. Here we have to find out the flux coming out from one face. So in this cube, how many phases are there? 6 phases are there. So what is the flux coming out from one face is equal to, since 6 phases are there, so flux coming out from one face is Q divided by 6 epsilon 0. Clear? So that is the final answer. Second question. The figure shows 3 charges as shown. Find the flux due to this configuration through the surface. So this is the figure given. Plus Q charge is here, Q charge is here, this is the surface, and minus 3Q is the charge outside. Okay, so this is the figure given. So the question is, find the flux due to this configuration through a surface S. So this is the surface given in the question. We have to find out the total flux coming out through the surface. Again we can apply Gauss theorem. We have phi equals charge upon epsilon 0. Here what is the flux passing through the surface? So here the surface enclosed 2 charges. What are the 2 charges? Plus 2Q and plus Q. These are the 2 charges enclosed by the surface. And minus 3Q is the charge outside the surface. So flux phi equals, we have Q represents the total charge enclosed by the surface. Here the surface encloses how many charges? Plus 2Q and Q. Therefore we can write 2Q plus Q divided by epsilon 0. Because minus 3Q charge is outside the surface. Okay, so it is equal to, final answer is 3Q by epsilon 0. So this is the flux enclosed by the surface, and if the surface also encloses minus 3Q, then we can take that minus 3Q also. But here in the given question, the surface encloses only 2 charges. Therefore flux is equal to total charge enclosed, that is Gauss's theorem, total charge enclosed divided by epsilon 0. So here it is 3Q by epsilon 0. Clear? Now pass on to the third question. 2 charges minus 2Q and plus Q are located at the points A0 and 4A0 respectively. What is the electric flux due to these charges through a sphere of radius 3A with center at the origin? Okay, so what is the electric flux due to these charges through a sphere of radius 3A with center at the origin? So from the given information we can draw a figure. So here this is the origin, then 2 charges are there, minus 2Q and plus Q. So here minus 2Q, what is the distance? It is at a distance A0. Okay, so this distance is equal to A. And where is the charge? Next charge is plus Q and it is placed at 4A0. So here let it be Q and it is at a distance 4. Okay, so both the charges are placed along the x-axis. Now we can draw a sphere. Okay, draw a sphere of radius 3A. So here this distance is A, this distance is 4A. That means we can draw a sphere. Here we can draw a sphere with O as the origin. Okay, so draw a sphere. So what is the radius of the sphere? Radius of the sphere is equal to 3a. Clear? So the sphere encloses how many charge? Only one charge, isn't it? Minus 2q is the only charge enclosed by the sphere, and q is outside the sphere. Again we can apply the same Gauss theorem. Phi equals q upon epsilon 0. Here also what is the flux enclosed by the sphere of radius 3a is equal to only minus 2q charge is enclosed. So here it is minus 2q by epsilon 0. This is the answer. Because q charge is outside the sphere, isn't it? So minus 2q charge is the only charge enclosed by the sphere, and hence the flux enclosed by the sphere is equal to minus 2q divided by epsilon 0.